All right, this video is for statistics, chapter 8 review. This is the review without proportions in it, so it really only hits sections 8.1 and 8.3. The main topic is confidence intervals. All right, and there is a review sheet that the students should have. It looks like this. It tells you which problems to do. All right, the first one we're going to look at is 8.2b. It says find the appropriate critical value for constructing a confidence interval in each of the following settings. And it says estimate a population mean for a 99% confidence based on an SRS size of 58. Okay, so the appropriate critical value is going to be a Z or a T. All right, and estimate the mean 99% confidence based on an SRS of 58. Okay, now either we know the standard deviation or we do not. If we know the standard deviation of the population, we are able to use a Z value. If we are not, we have to use a T. So I'll just show how to do both. In this case, since it's an SRS, we are unlikely to know the standard deviation of the population, so T is more appropriate. Okay, so when I run the program, all right, and I go down to find a Z or T. Okay, let's just do a Z. I know the probability between 99. Okay, and if I'm doing a Z, then my values are plus or minus 2.58. More likely, we would have to use a T value. Okay, so if I go back to find a Z or T, go down to T. Okay, I know the probability between is going to be 0.99. And my degrees of freedom is 1 less than 58, so my degrees of freedom is 57. And it's thinking. And the T value there is 2.66. The T value will always be greater than the Z value. And the larger the sample size, the more these two approach each other. So the T gets closer to the Z doesn't move. Okay, the next one's on batteries. It says a company that produces AA batteries tests a lifetime of a random sample of 40 batteries using a special device designed to imitate real-world use. Based on the testing, the company makes the following statements. Our AA batteries last an average of 430 to 470 minutes, and our confidence in this is 95%. Okay, determine the sample mean and standard deviation. Okay, all right. So in this problem, okay, what we would have to do is first we recognize that there are 40 in a sample, okay, and in this case we have confidence level 95% and an interval of 430 to 470. Okay, so directly in the center of that is the mean. So all confidence levels are centered at the mean. Okay, so we just have to kind of figure out the middle of those two. You could add them together, divide by 2 would be one way to find it. All right, and again, we're back to do we know the standard deviation of the population? Okay, and they might know it, they might not. So if we don't know it, we should use a T value in order to calculate this. So our actual formula is statistic plus or minus the T value times the standard deviation, standard error of estimate, okay, of what we're looking for, okay? So in this case, we have 450 plus or minus, okay, our T value, and if we've got N of this, then our degrees of freedom is 39. It's 1 less than it. Okay, so 95% confidence level with, let's run that again, okay, so from here, I'm going to go to the next menu, find a Z or T, find a T, okay, and from here I know the probability between is going to be 0.95 because it's a 95% confidence level. My degrees of freedom is 39, and in this case my T value is 2.02, so 2.02. Okay, all right. What else do I know? I'm looking for the standard deviation of x bar, okay, and the sample size of 40 would go on the bottom right there. And S of x goes on top. All right, so we have S of x in both these locations, not standard deviation of x bar. This whole thing is the standard deviation of x bar. Okay, so the piece we're missing is the standard deviation of x. We know the error is 20 because we're centered at 450 and we went down to 430 and up to 470. Okay, so this is S of x we're looking for, and this error piece in the formula has to be 20. So again, 20 was 450 to 470 or 450 down to 430. So that distance is 20. This is the portion of the formula that does that. Okay, so the S of x that I'm looking for can be set up like this: 20 equals 2.02 times the standard deviation divided by the square root of 40. Okay, so why not just take the 2.02 and divide by the square root of 40? Divided by the square root of 40, and that will give us 0.319. So I have 20 equals 0.319 S of x. I'm just going to divide 20 by that answer, and I end up at 62.6. Okay, we could do a little bit less work if we treated it like a z-value, as if we knew the standard deviation, but we don't know. It didn't tell us that we knew in any case. All right, a reporter translates the statistical announcement into plain English as follows. If you buy one of this company's AA batteries, there's a 95% chance that it will last between 430 and 470 minutes. Comment on this interpretation. Typically when you get these questions, the interpretation is wrong, and we're supposed to fix it. So the way we've been saying it in class is we are 95% confident that the true average would fall between 430 and 470. So 95% of the time it will fall between here. This would capture this using this method. Okay, so the method we used would be accurate 95% of the time. It's not necessarily there's a 95% chance that it will last between these two values. All right, your friend who has just started studying statistics claims that if you select 40 more AA batteries at random from those manufactured by this company, there's a 95% probability that the mean lifetime will fall between 430 and 470. Do you agree? Explain. Okay. Our job with a confidence interval is to estimate the mean. Okay. So we're not saying that future values are going to fall between this. Okay. We're saying that the true value, the true parameter, the mean, is between these two values. Okay. So one more time, they said you select 40 more AA batteries at random, okay, from these manufactured at this company. There's a 95% probability that the mean lifetime will fall between here. Okay, that's not true. Okay, so the first time we ran the study, our job was to approximate the average life of a battery. And the average was predicted to be between 430 and 470 of our sample. That's what we got. That doesn't mean future samples will give us that. Okay, so samples can fall in different ways. All we're saying is that we're 95% sure that it's between these two, the true average. So what we would be sure of is that if we followed it again, we would have a new interval, and we'd be 95% sure that the true mean was between there. It doesn't mean that we're going to end up with the same interval again. All right, give a statistically correct interpretation of the confidence interval that could be published in a newspaper report. Okay, so we are 95% confident that the true average life of the AA battery is between 430 and 470 minutes. That's the right way to say it. All right, next problem. Smart kids. A school counselor wants to know how smart the students in her school are. She gets funding from the principal to give an IQ test to an SRS of 60, so sample size is 60. Of the over 1,000 students in the school, the mean IQ score was 114.98 and the standard deviation was 14.8. All right, describe the parameter mu in this setting. Remember that statistics are supposed to estimate parameters. Parameters for the entire population. So P parameter, P population. So mu would be for the entire population, and it's a mean. And what are we finding the mean of? We're looking for the mean IQ score of all students. And the job of the study would be to calculate x bar. X bar's job is to estimate mu. Explain why the normal conditions is met in this case. The normal condition is met because our sample size is greater than 30. So we can use a normal curve in order to find probabilities. Okay. Next, construct a 90% confidence interval for the mean IQ score of the students at the school. This is a sample, so we should be doing a t-test on mean. So when I go to the confidence interval, I'm going to do a t-test on mean. Okay, my sample size here was 60. My x-bar was 114.98. And my sample standard deviation was 14.8. Confidence level is 90. All right, so my critical t-value is 1.67. All right, my degrees of freedom was 59. Those two go together. My standard deviation of x bar, which took the s of x and divided by the square root of 60, was 1.91. That is the average distance away from the true value we would expect the 114 to fall. And then my interval is 111.8 to 118.2. So the confidence here was 111.8 to 118.2. Interpret results from Part C in context. So we are 90% confident that the true mean IQ score of students at the school is between 111.8 and 118.2. So the school is pretty smart because the average is really around like 100 for the general population. All right, let's go to 8. Engine parts. Here are the measurements of a critical dimension of an SRS of 16 of the more than 200 engine crankshafts produced in one day. So we've got all these values right here. Okay, construct and interpret a 95% confidence interval for the process mean at the time these crankshafts were produced. So what you would do is you type all these values into L1. Okay, you could run basic stats, or you could run a t-test on L1. It will give you all the information you need. All right, in the interest of saving time, I'm going to say that we know the mean. Okay, and the mean in this case was 224.002. Okay, so x bar was 224.002. Okay, and s of x in this case was 0.0618. Our sample size was 16. Okay, which means that our degrees of freedom is 15. We would need our t-value, okay, in order to do this, because we're going to add and subtract off of this to get our confidence interval. So, running the app, okay, confidence interval. Right? If you had all the data in L1, you can run a t-test on L1. I'm just going to run a t-test on mean. Okay, my n was 16. My x bar was 224.002. Sample standard deviation of 0.0618, which again, sample basic stats will run on the L1. Confidence level in this case was 95. And our critical t-value is 2.13. That should be listed. It goes with the degrees of freedom and the confidence interval. All right, our error is 0.033. And so our confidence interval is 223.96, so 224 to 220. Wow. Okay, so this is really tight, so I'm going to actually be a little bit more precise. 223.97 to 224.03. And there is our value. Okay, that's our interval. The process mean is supposed to be 224, but can drift away from this target during production. Does your interval part A suggest that this process mean has drifted? Explain. All right, so what you want to look for when they ask you to compare to a value is the value in the interval. The answer in this case is yes. It is captured by this, so it is still considered reasonable. Okay, so if the entire interval were above or below this number, we would say we should probably re-examine this or think that the production has caused it to drift. All right, good wood. A lab supply company sells pieces of Douglas fir 4 inches long by 1.5 inches square for forced experiments in science classes. From experience, the strength of these pieces of wood follows a normal distribution, okay, with standard deviation of 3,000 pounds. All right, so my standard deviation is known at 3,000. You want to estimate the mean load needed to pull apart these pieces of wood to within 1,000 pounds. So we want the error to be 1,000, okay, with 95% confidence. So we can use the z-test because we know the standard deviation of the population. And in a 95% confidence interval, we use 1.96. Okay, how large a sample is needed? Show your work. All right, so the formula here for error equals the critical z-value times the standard deviation divided by the square root of the sample size. We know everything except for n, so we're going to go 1,000 equals 1.96. Okay, square root of n is here, and then we have 3,000 on top. Okay, my preferred way to do this is to take the 1,000 over 1, multiply these top numbers here. Let's figure 1.96 times 3,000. End up at 5880. Square root of n. I'm going to cross multiply and divide. So the 5880 is going to multiply by 1 and divide by 1,000. And I end up at 5.88 equals the square root of n. I now square both sides and end up at 34.5, which we need to say 35 people, or pieces of wood. So pieces. All right, it's about ME, which is probably margin of error. Explain how each of the following would affect the margin of error of a confidence interval if all other things remained the same. Increasing confidence level causes the error to increase, error up. So if we go from 90 to a 95, the error goes up. Quadrupling the sample size, anytime we increase the sample size, the error goes down. All right, so there we go. And it says 8.2, the weights in pounds of 3 adult males are 160, 215, and 195. The standard error of the mean for these 3 weights is what? Okay, so first I need to find the standard deviation of that sample. Okay, so stat, edit, just put these values in here. 160, 215, 195. Okay, and all I have to do is run basic stats. Okay, so if I run basic stats, and I can do variable stats. Okay, or I can just run basic stats from the app, but I need this S of X number, 27.83. I have to divide that by the square root of the sample size. Okay, so if I take the 27.83 divided by the square root of 3, I'll end up at 16.06. Okay, so 16.07 is D. In preparing to construct a one-sample t-test for the population mean, suppose we are not sure if the population distribution is normal. Okay, so we can't use normal since we don't know that it came from normal. In which of the following circumstances would we not be safe to construct the interval based on an SRS of 24 from the population? Okay, so 24 hasn't reached the 30 standpoint, so we don't have this central limit theorem yet. So at 24, what would really mess us up would be knowing that there are outliers or major skew. Something like major outliers is probably going to be the thing we're looking for here. Okay, so it says a stem plot is bell-shaped. Would be good to go there. That's not a worrisome thing. A histogram shows slight skewness. We're probably not worried about slight skewness with 24. If we're under 15, we're worried about skew, but not at 24. Okay, a stem plot of the data has a large outlier. Yeah, so the outlier is going to mess us up. Okay, sample standard deviation is large. Doesn't matter. That doesn't affect the shape. Okay, the T procedures are robust, so it is always safe. Okay, not true. Okay, so the sample size dictates how confident and how sure we are that we can proceed with all our curves. 8.55. You want a 90% confidence interval for the mean of a population with a known population standard deviation. Okay, so unknown population standard deviation means we have to use a t-value. All right, the sample size is 30. The value of t you would use for this interval is what? Okay, program. Okay, find a z or t. Looking for a t. I know the probability between because I'm looking for a 90% confidence. And my degrees of freedom was 29 because we are one less than 30. And we have 1.699. Okay, so 1.699 was B, and that's our answer. Okay, 7. 90% confidence interval for the mean population is computed with a random sample and is found to be 9 plus or minus 3. Which of the following could be the 95% confidence interval based on the same data? All right, the same data could be a 95%. All right, so first it's got to be centered at 9. Anything not centered at 9 is out. Okay, whatever. All right, now, we don't know if they did a Z or a T, but we do know that if we go from a 90 to a 95, then this number, the error, has to get larger. So smaller, no. Smaller, no. Same, no. Larger, yes. Okay, so 8.7 D makes sense. That's the only one that gives us a more error. So when you go more confident, you have to widen your error or margin of error. 8.8. Suppose we want a 90% confidence interval. Okay, 90% confidence interval for the average amount spent on books by freshmen in their first year at a major university. The interval is to have a margin of error of 2. Based on last year's book sales, we estimate that the standard deviation of the amount spent will be close to $30. The number of observations required is closest to what? Okay, so this is the missing sample size problem. Okay, and what we would need to know is that the error is equal to the z or t. All right, and since we have the standard deviation from last year, we're going to say that we know it. So we're going to go with the z times the standard deviation divided by the square root of n. Okay, so we want our interval to have a margin of error of 2. Because we're using a z at a 90% confidence interval, I believe it's 1.69, but I will double check. Yeah, 1.64. I did find a z or t, z. Okay, the first time I did it, I ended up at 606. And the two answers here are 608 and 609. So I'm guessing that I have to be between these two values. So I'm going to use just more accuracy here on my z value and see if that gets me closer to the values that I need. So if I did 2 equals this, 30 square root of n. So I'm just using more accuracy. All right, now I have 2 over 1 equals 49.3455. 49.3455. And that is larger than that. Okay. Square root of n. Multiply by 1, divide by 2. Okay, so now I have 24.67275 equals the square root of n. Square that value. 608.7, which we have to go 609. Got it. Okay, so I needed more accuracy than what I had there. A Census Bureau report on the income of Americans says that with 90% confidence, the median income of all U.S. households in a recent survey was this, okay, with a margin of error of 742. This means that what, okay? And again, they gave us 4 different options here, so let's just say what it means. We are 90% confident, okay, that the true average, okay, what we're looking for, the true median income, okay, is this with plus or minus 742, and it gives us a confidence interval that we can calculate. All right, so let's see what we end up with here. The one that's going to make the most sense, all right, here we go, D. The Census Bureau got the result of this plus or minus that. using a method that will cover the true median income 90% of the time when used repeatedly. So we talked a lot about how 95% confident means we're going to miss 1 out of 20 times. Okay, miss meaning the true thing we're looking for, in this case the median income, would be captured in the interval. Okay, so using this process, okay, we would be right 90% of the time. So it would capture the true or cover the true 90% of the time. So D is the one that actually works there. All right, how many people live in South African households? To find out, we collect an SRS of 48. Okay. Out of the over 700,000 students who took part in this census, okay, the mean of this was 6.208. The standard deviation was 2.576. Okay, part A says, is the normal condition met? In this case, sample size is 48, so we're good to go. Justify your answer. B says 95% confidence interval for the population is 6.0208 plus or minus 1.96 times this. Explain why this interval is wrong, then give the correct interval. Okay, so first, this is a z value. Okay, we would have to use a t value because we do not know the standard deviation of the population. Okay, so the 1.96 is off. Okay, so there we could explain it. Also, this value here, I'm not sure where that value came from. Okay, the 3.72, because what we would do is use the 2.576 and the square root of 48 on the bottom. So he's got all kinds of errors through this process. So let's run the app, and we're going to go to confidence interval, and we're going to go down to a t-test on mean, and our n is 48. Okay, our x bar is 6.208. Our sample standard deviation is 2.576. Okay, confidence level he used was 95. So we end up with an x bar of 6.02. Our t value, which is what would be in that place, would be 2.01. Okay, the standard deviation would have been the point. Well, shoot. Yeah, they messed that up. Okay, all of this could have been 0.372. Okay, so that's what all of this is meant to calculate. So the way we get that is the standard deviation divided by the square root of 48 ends up being this. You wouldn't divide by the square root of 47 again. Okay, and then the actual value, the interval, is 5.46 to 6.96. So that was 5.46 to 6.96. All right. This one says milk processor monitors the number of bacteria per milliliter in raw milk received at a factory. The random sample of 10 supplied with one produce gives the following data. Construct or interpret a 90% confidence interval for the population mu. So you'd put all these values in L1 and just run the test. Now, when you do that, you end up with an interval of 47945105, and the t-value you'd end up with there, just to check our work, is 1.833. All right, so that should help you out.